In this section, I want to give you a full picture of the transmission line. Up to this point, we talk about the transmission line, and at the end of the transmission line, we have a load attached to some applications, but we haven't talked about the generator. So that's the talk about the full transmission line. And the reason we talk about the full transmission line is that we are still missing one value for the forward voltage. Well, let me first tell you again the general solution for the voltage and current right here. For the general solution, you have a forward voltage, backward voltage, and forward current and forward backward current. And turn out that from the reflection coefficient expression, which is the reflected signal divided by the forward signal, and you can, for example, express the backward voltage as a function of the forward voltage. And also from the characteristic impedance given by this expression, you can also express your forward current as a function of your forward voltage. So basically, your backward voltage or forward current can be calculated from the forward voltage, but at this moment we don't know the value for this forward voltage yet. And if you combine this expression and this expression, you can also express the backward current as a function of the forward voltage. So basically, in these two expressions, you have four unknowns: V0 plus, V0 minus, I0 plus, I0 minus, and you know everything except this V0 plus. And the purpose of this session is to find out what V0 plus is. And we need one more boundary conditions. And this one more boundary condition is the generator of the circuit. So let's first look at the part we have learned about a transmission line with a load, and we learned about the impedance transformation. So we can calculate the impedance at this point looking into the load, and simplify this circuit into this equivalent circuit, just having input impedance right here. And this AA, these two nodes will coincide with this node. And then we can append this circuit with the generator. And in general, a generator will have a generator impedance. And then you put this generator circuit into this equivalent circuit. And for this configuration, we don't have the transmission line anymore. It is just a lump circuit. So we can use a lump circuit analysis to do the calculation and figure out the input voltage and input current for this circuit. So let's do it now. Suppose I want to know the VI, the input voltage into this transmission line, but we have lumped the whole transmission line into a simple impedance called input impedance. So we can derive this voltage from the generator voltage by doing this calculation, because Vg divided by Zg plus Zin is just the current flowing into this circuit. And if you multiply the current flowing into the circuit with the input impedance, then you end up having the input voltage. And in this expression, you already know that for transmission line, the voltage across this AA prime points is given by this general solution. So with this general solution, you can move this complex exponential to the left hand side, and then you end up having the V0 plus, the forward voltage given by this expression. With this, basically you know everything about the transmission line. You know the four unknowns in the general solution of the transmission line. And don't forget that this Zin has been calculated from the impedance transformation given in the last session. So in the final section of this lecture, I told you that the whole purpose of putting in the generator circuit is to figure out the forward voltage. And once you figure out the forward voltage, then you have all the other values for the voltage and current on the transmission line. And once you finish your calculation, you end up having the forward voltage equal to this, which is derived from the generator voltage, and also the input impedance of the line, and also the generator impedance. And the last part of this expression is due to the propagation of the signal on the line over a distance of L. So this is the section 3.4. I hope that now you have a full picture of the transmission line.